Hi there everyone, and welcome to this GCSE Maths lesson. I'm your host for today's session, Melissa Lieberman, and you can contact me anytime using the details there on your screen. My phone number there, 0800 092 0070 if you need any help with maths. You can also email me anytime, mathsteacher@icslearn.co.uk. So today we're going to be covering some more algebra. The reason I've called this further algebra is because that's the name of the corresponding chapter in the textbook. But actually what we're going to be covering is how to multiply out double brackets. So what I mean is multiply one bracket by another bracket. In your textbook it calls this multiplication of binomials, but don't worry about that language too much. It should become clear what I mean by that when we go through examples. And we'll also look at the reverse process, which will be taking quadratic expressions. That's expressions in a single variable with a squared term in, but you'll get used to these once we go through them. And we'll also include a special type of quadratic, which is called a difference between two squares. It's not always a quadratic, but it's a form that you need to be familiar with. I'll try to keep to within 1 hour, but sometimes I go a little bit over, so we'll see how we do with time. Welcome to everyone who's watching me live, and please do feel free to interact with what I'm doing. Type in the chat box if there's anything you want to ask me or anything you don't understand. Probably there'll be other people who don't understand it as well, and so on. So don't feel embarrassed is what I'm trying to say by asking me any questions. If you just type it in the chat box, I'll do my best to help you out. Answer questions as I go through. That way I'll be able to see whether you're following me, and I can spend a bit more time on it if there's something that people aren't understanding. I always advise that you make notes as you watch these lessons. That will be part of the learning process and will give you something to study from later on. So you'll have your own bank of notes as you work through these lessons and write things down. You'll also need to spend time practicing questions. Especially for topics like this, it's really important that you practice as many questions as possible. And you do have some practice questions on your ICS Learn student community. This corresponds to this section 3 in study unit 3. If you've completed test paper 2, then you should have access to your study unit 3 materials. I'll just give you a link to it here. So these links, as always, which I'm pasting in the chat box, are active. So if you click on them, they'll open up for you. If you're watching the streamed WebEx version of this, you might need to open up the chat box. Just click on a view on the menu bar across the top, or you'll see a little red box at the top of this. If you click on that, then you'll be able to open up the chat panel. And if you can also move these windows. So if the little video clip with me in it is getting in your way, you can move them up to the top of the page and give yourself more of a view to see the slides, just in case you've not watched these before. If you're watching the YouTube version, as always, I will paste in the links at the bottom. So there's a link to some practice questions on your student community page. For more depth and more understanding and much more practice questions, you have your textbook, chapter 13. This is a topic which is new to foundation tier, so there's a whole chapter on it in your foundation tier book. And even if you're doing higher tier, I would advise starting with the foundation tier chapter. You'll be doing a lot more of work with quadratic expressions at higher tier, but do the foundation tier chapter first. Chapter 13 in the higher tier book if you want to try the more complex quadratic expressions, but it's perfectly fine to start with the foundation tier chapter and then try the higher tier one later on when I cover those topics in unit 4. Oh, let me just give you a link. I almost forgot. Here's a direct link to the chapters, both in the higher tier book and the foundation tier book. And of course, the answers are downloadable from your ICS Learn student community. So there's a direct link to those chapters so that you can practice some of these questions. So this is really grade 5, a grade 5 topic, which is old GCSE grade B. So it will be assessed at both higher and foundation tier. So here's what we'll be covering this session. We'll be looking at 2 methods for multiplying out double brackets. I'm just using that language rather than multiplying binomials. Binomials are just expressions with 2 terms in them, but that's the language that's used in your books. The language is less important than the method. 2 methods will be a grid method, which is very similar to the grid method that you use for multiplying numbers. And then we'll look at what is sometimes called FOIL method. FOIL, F-O-I-L, stands for first, outer, inner, and last. We'll go through that in a minute. And then we'll look at how to do the reverse of multiplying out double brackets, factorising double brackets, putting them back into brackets. So you're given an expression. You need to put it into brackets, that's multiplying it out, and then factorising it is factorising is putting it back into brackets. And then we'll look at a special case, which is factorising a difference between two squares. Please make sure that you've worked through the basic of brackets and factorising first, so that you know how to multiply out simple brackets and factorise expressions as well, because sometimes we factorise things by putting them into one bracket. Sometimes we factorise things by putting them into two brackets. So you need to be really familiar with the basic brackets and factorisation first before you move on to this topic. So there's a link there to the YouTube version of that lesson. So this slide is just a recap of the method that we met before for multiplying out a single bracket. So remember that when we have a term, so in this example that you see on the screen here, we've got a term x in front of a bracket, and the bracket contains two terms, and the two terms are 2x and minus 3. We need to multiply both terms in the bracket, 2x and minus 3, by the term outside the bracket, so we end up with two terms. So we have, let me just turn on my little rectangle tool here. So we need to work out x times 2x first of all, which gives us 2x squared. And then we need to work out x. I'm just going to turn on the pen tool here. And then we need to work out x times minus 3x, which is times minus 3, which is minus 3x. So that gives us 2x squared minus 3x. But hopefully you can do these really easily by now, and the reverse process, which would be if you were given the expression 2x squared minus 3x and you were told to factorise it, you would put it back into the form with the bracket. So that's single brackets. What happens when we have a bracket multiplied by another bracket, which does happen? Here's an example. So what this means is we've got two expressions, x plus 1 and x plus 4, and we want to multiply them together. How does that work? Remember that there's an invisible multiplication sign between these two brackets. So what we're doing is we're multiplying x plus 1 by x plus 4. And the way it works is that every term in the first bracket is multiplied by every term in the second bracket. So x multiplies the x in the first bracket multiplies x plus 4, and the one in the first bracket multiplies x plus 4, and then we tidy it all up. One way of doing this is to use a grid method, sometimes called a box method. So there are two terms in each bracket, so we draw a grid 2 by 2 like this with the times operation there in the top left hand corner. I can see some people are trying that out already, which is fine, but let me go through it step by step. And what we do is we put the terms from each bracket along the top and down the side. So if we put x plus 1 in there, so this bracket has got two terms, x and plus 1. Don't forget the sign. Remember, the sign is kind of, the sign in front of the term is attached to it. So we put x plus 1 in there. And then down the side we put x and plus 4. So we put x and plus 4 down that side there. And then we're going to go through and multiply each row and each column by the term that's at the top of it. So in this first box here, we want to multiply x times x. X times x, remember, is x squared, x to the power of 2. So in there we write x squared. Then if we work out this box here, we've got x times plus 1, which is just plus 1x. Now, normally you don't put the 1 in algebra, but I'll just keep it in there for now for clarity, so plus 1x. Then in here we have plus 4 times x, plus 4x. And then lastly, we've got plus 4 times plus 1. In other words, just 4 times 1. And 4 times 1 is plus 4. So altogether, we've got 4 terms, x squared plus 1x plus 4x plus 4. So we write those out like that. Let's see. So Ikra and Rob, it looks like you've got that right, because remember there's a further step, which will be to collect together like terms. It will take a lot of practice to do that at one step. So write this out first, and then we look for any like terms. Now, an x squared can't be added to an x, but x's can be collected together. And we've got 1x plus 4x. So we collect those together to make 5x. So altogether, we've got x squared plus 5x plus 4. So that's the simplified form. Once it's written like this, x squared plus 5x plus 4, we can't simplify it any further because each of these terms, you've got one term in x squared, one term in x, and a number or a constant. This is called a quadratic expression, and it's got the form ax squared plus bx plus c, which you may have met before. A, b, and c are just numbers. So a, b, and c might be 1, 2, 3, so then it would be x squared plus 2x plus 3 or so on. So they can just be any numbers, positive or negative, and that's what we call a quadratic expression. Most of the expressions which we'll be dealing with in this lesson will be quadratic expressions, but it's possible to have different terms in double brackets. So double brackets don't always lead to quadratic expressions, but all of the examples that we'll be doing today will, because that's the form that they'll take in your GCSE maths exam. So here's a couple of other examples. I will go through them step by step. I realise people watching might have done these before, but because this is a topic that's new to foundation tier, there will be students out there that have never done this before. So I'm going to do lots of examples and go through them all step by step. Do feel free to jump ahead and answer it. If you've had the practice, if you've done them before, you can answer them quite quickly. So I'm going to do one more example using this grid box method. This time we've got x plus 4 times 2x minus 5. So every term in the first bracket needs to multiply every term in the second bracket. So we'll put all our terms in a grid like this. So we'll put x plus 4 across the top, x plus 4 like that, and then down the side we'll put 2x and minus 5. Don't forget the minus sign, that's very important, like that. Then we'll go through and we'll multiply our terms together. So in this box we've got 2x times x. That gives us 2x squared. Remember, the number always comes first. In the next box we've got plus 4 times 2x. 2 times 4 is 8, so that's just plus 8x. Got a few answers popping up on my screen which we'll check in a moment. Well done. X times minus 5, minus 5x, and then 4 times minus 5. Don't forget the minus sign. 4 times 5 is 20, so we've got minus 20. And then we collect together those terms. So writing each term out, we've got 2x squared plus 8x minus 5x minus 20. And these two x terms that we've got there in the middle, they won't always be in the middle. It depends what order you've multiplied your brackets in. I think, Ikra, you've seen an error that you've made, but not to worry, let's have a look. So we've got 8x minus 5x, don't forget the signs, gives us 3x altogether. So the final expression when we multiply at this bracket will be, are you ready? 2x squared plus 3x minus 20. Let's have a look. Rob, you got that first and you got it perfectly right. Ikra, I'm not sure why you got an x cubed in there, but you've corrected it a little bit later on, but that's correct. Simon, you got it right first time. Perfect. It looks like everyone's got it right. X squared plus minus 20. Very good. Okay. Now, sometimes this box method is helpful, but with practice you probably won't use this box method. Again, we've ended up with a quadratic expression. In this quadratic expression, the letter in front of the x squared, coefficient of x, a is 2, b is 3, and c is minus 20. Those of you doing higher tier will need to really know how to identify these coefficients, because we'll be using them later on to solve quadratic equations. If you're doing foundation tier, don't worry about it too much, because you don't need to deal with more difficult examples. But this is something, if you're doing higher tier, you'll be doing a lot of these. Foundation tier, just need to know the basics that I'll be doing today. So how about this FOIL method? What's that all about? Well, this is the way that most people normally work this out, and the F, O, I, and L is just a way of keeping track of the terms. F stands for first, O stands for outer, I stands for inner, and L stands for last. Let's see how that works. So here's another example. If you want to try multiplying it out, typing the answer on the screen, have a go. It's a slightly more complex example with some minus signs in it. But first of all, we multiply the first term in the first bracket by the first term in the second bracket. And drawing these little lines is really helpful. So first is the first term in each bracket. 2t times 3t. That's 6t squared. 2 times 3 is 6. And then t times t is t squared. Be very careful, it's multiplying and not adding. You'd be surprised how many people write that as 5t squared. It's 2 times 3, which is 6t squared. O is outside, so multiply the outside terms in each bracket first. So we've got 2t times minus 2, be careful of the minus sign, 2t times minus 2 minus 4t. Then I stands for inner, so or inside, we've got the two inside terms here. Looks a bit like a smiley face when you've finished. Minus 1 times 3t is minus 3t, so we put that in there. And then last, we've got the last term in each bracket, minus 1 times minus 2. And here we've got a negative number multiplied by another negative number, so the result is going to be positive. Minus 1 times minus 2 is going to give me plus 2. Please be careful of the signs. Plus 2. So we bring together any like terms as the last step. So we've got here minus 4t minus 3t. That makes minus 7t altogether. Not 70, but 7t. Minus 7t, like that. Sounds like 70, doesn't it? Sorry. So altogether, so I'm just noticing that Michael's saying, where did the minus 1 come from? Oh, I see. I think I made a mistake. I do apologise. Is that why nobody was answering the question? I think I wrote it and then I didn't update the question. I do apologise. Let me just have a look. So we've got 6t squared minus 7t plus 2. So what I probably did is I had, see, I've written minus 5 there, but then the example I've multiplied out is minus 1. So that example should be, I'm sorry, that the example that I wrote is different to the example that I multiplied out. I'll update that when I go back to my desk. So what we've multiplied out there is 2t minus 1 times 3t minus 2. I do apologise. Just change that minus 5 in the example to a minus 1. You do know that all these examples are just made up anyway, so I just worked out the wrong thing. If that makes sense. Yes, I'm going to do plenty of examples. I've got a whole screen full of them. So that's the basic method. Here are some examples. Hopefully that will be enough for you for now. And then it will just be a matter of practice. Practice as many questions as you can until you get used to the method. That's all I can suggest, is just do as many as you can. So let's go through each of these. If you're watching the recorded version, you may wish to pause, try them out yourself, and then press play, and I'll go through each of the answers. So the first one here, quite a simple one, it's got pluses in it, and we'll work this out step by step. I'm just going to use the FOIL method, so multiplying each term in the first bracket by each term in the second bracket. So here we've got a plus 2 times a plus 3. You can try and work it out if you want, you might be able to. First step is to multiply a times a, so the first term in each bracket. A times a is a squared, so write that down. And do draw these lines when you're working these out, it will help you. Then we need to multiply a by plus 3. A times plus 3 is plus 3a. Then we've got the 2 times a, so 2 in the first bracket times a in the second bracket. That gives us plus 2a. And then lastly, we're going to multiply the plus 2 in the first bracket by the plus 3 in the second bracket. So that gives us plus 6. That is an expanded form of that bracket, but we can collect together some like terms. We've got 3a and 2a in the middle there, if we work them out in this order. 3a plus 2a is 5a. So altogether, we've got a squared plus 5a plus 6, and that's our expanded form of that bracket. In a moment, we'll look at factorisation, and that's where we start with the expression a squared plus 5a plus 6, and we put it back into brackets. But don't worry about that for now. Practice multiplying out, and then you can practice putting back into brackets. Right, this next example is w minus 1 times w minus 5. There's two minus signs in here, so we need to be careful of signs. So first step, w times w, w squared. Next step, w times minus 5 is minus 5w. Next step, minus 1 times w is just minus w. You don't need the 1 there in front. We can just write it as minus w. But remember that there is an invisible 1 in front. And then lastly, minus 1 times minus 5. Be careful of signs. If we multiply two negative terms together, we're going to get a plus sign in front. So minus 1 times minus 5 gives us plus 5. Now we need to collect together any terms that have the same letter in them. Not the w squared, that's a different term, but we've got minus 5w minus w. So minus 5w minus 1w minus 5 minus 1 is minus 6. So in the middle there we've got minus 6w. So altogether that comes to w squared minus 6w plus 5. Right with that? And looking down the list, it looks like everyone's got it right. W squared minus 6w, perfect, perfect, perfect. So 4 people who are following this: Rob, Michael, Ikra, and Mutsa. I hope I said your Muaza. Hope I said your name right. I've got it right. How about this next one? So this time we've got slightly more complicated terms. We've got some more numbers in front of the letters here. So just go through term by term. It's always the same. 3t times t is t squared. 3t times minus 4 is minus 12t. T, or plus 1 times t, remember the letter always comes first and we don't need to put the 1 in front, plus t. And then plus 1 times minus 4 is just minus 4. Like that. Collect together like terms. This time we've got, oops, let me just go back one so we can think about it. This time we've got minus 12t plus t, so that's like minus 12 plus 1, which is minus 11, minus 11t in the middle, which gives us 3t squared minus 11t minus 4. Now this is an interesting one. We've got 2p plus q times 2p minus q, and this is going to give us a special result which you may have met before or not. Let's have a look. 2p times 2p, 2 times 2 is 4, and p times p is p squared. So we've got 4p squared. Then we've got 2p times minus q. Remember the letters, if there's more than one letter, should go in alphabetical order. So that gives us minus 2pq, like this. Then we've got q times 2p, this time it's positive. We've got plus 2pq. The letters are in the same order, so these are like terms in the middle here. And then we've got plus q times minus q. That gives us minus q squared. So I'm just seeing, Sasha, what you're working on paper is not what I'm doing at all. I'm not quite sure. If you send me a photo of what you're working out on paper, then I'll be able to look at it. But basically what we're doing is we're multiplying every term in the first bracket by every term in the second bracket. So we've got 2 terms in the first bracket, 2 terms in the second bracket, and we just need to work in a systematic way to make sure that every term in the first bracket multiplies the 2 terms in the first bracket. Every term and the second term in the first bracket multiplies the 2 terms in the second bracket as well. Does that make sense? So these arrows here are just showing you which terms I'm doing. You could do it in a different order, but it's usually easier to start with the first term in the first bracket, multiply that term by the 2 terms in the second bracket, then go on to the second term in the first bracket and multiply that term by the 2 terms in the second bracket. Does that make sense? Right. So what do we get then? When we multiply plus q and minus q, we get minus q squared. And we've got 2 like terms here. We've got minus 2pq plus 2pq. What happens? Well, these just add together to make 0. They cancel each other out. So they just disappear. We don't need to write 0pq or anything like that. We just don't write them down at all. The 49 should be a 4. Oh, I see. Yes, when you wrote 14, I think you meant it was 4x. So the 9 should be an x, I think is what you mean. So that should be 4x squared plus 4pq. So be careful here because we've got minus 2pq plus pq. So that means you've got no pq's altogether. They've cancelled out. Does that make sense? If one is plus and one is minus, then you'll have none of them. Subtract pq. So the 2 inner terms in this example cancel out, they just become 0. And we're just left with 4p squared minus q squared. And this result is called difference between two squares, and this will come up more. I'll show you the basic methods for today's lesson, but as I said, this will take a lot of practice, so make sure you spend a good few hours. As Sasha says here, it's just a matter of practicing lots and lots of examples before it will just click and fall into place. So the method is the same, you just keep doing it and practicing, and it should get easier with practice. But you do need to be aware of this result, difference of two squares, but I'll go back to it in a minute. So 4p squared is a squared term, and q squared is a squared term. Now how about this last one? This says a minus 2b squared. What does that mean? Remember, when something is squared, it means it's multiplied by itself. So all this means is a minus 2b times a minus 2b. So we've just got two brackets here. Be very careful, don't square both terms. It won't be a squared plus 4b squared. That's not quite right. You'll lose the terms in the middle. So when you see something squared, I advise that you always, as a first step, write it out as two brackets like this. If it was cubed, there'd be three brackets, but then that's a bit more complicated. So squared like this, we've got two brackets, and then we just use exactly the same method as before. We multiply everything in the first bracket by everything in the second bracket. So multiply the a in the first bracket by the a in the second bracket, we've got a squared. Multiply the a in the first bracket by the minus 2b in the second bracket, we've got minus 2ab. Remember, the letters go in alphabetical order and the number goes at the front. Then we've got the minus 2b in the second bracket times by the a in minus 2b in the first bracket times by the a in the second bracket. So minus 2ab. And then lastly, we've got minus 2b times minus 2b, which is plus 4b squared. Happy with that? Lorena, a squared plus 4b squared, but don't forget the minus 2ab minus 2ab. These don't cancel out this time. So when you collect these together, minus 2ab minus 2ab is minus 4ab. Perfect, Simon. So yes, a squared minus 4ab. It looks a bit, because I know you can't type a power button on the screen, so I have to look at quite closely at those, but it looks like, yes, good. Simon, be careful because it should be a minus 4ab, and I know you've corrected yourself further down there. Perfect, minus 4ab. So altogether, this is equal to a squared minus 4ab plus 4b squared. I know it just looks like gibberish like this. Bear in mind, algebra is like another language, so what we're writing makes logical sense. Don't try to think too hard about what it means. Quadratics come up everywhere in maths. If you do A-level maths, there's quadratic curves, and you need them all the time to solve problems in maths. So this is something, the more maths you do, this will be what you'll be using all the time. So it's a really, really important topic in maths. You've got your caps lock on, Lorena. It's like you're shouting. Yes, do just trust yourself more. It will just come with confidence. The more practice you do, the easier it will be. And after a while, you'll just be doing them really easily, and it will just get better with practice. So let's have a more detailed view of squaring brackets. So what I would advise is, if you see a squared bracket like this, don't cut corners. Write it out as two brackets and multiply it through term by term. You might spot a pattern which will allow you to expand it more quickly, but I think it's better to make so you don't make mistakes, that you write it as two separate brackets. So supposing we're asked to work out x minus 3 squared. The first step will be to realise that that means x minus 3 times x minus 3. So we write that down. That does not equal x squared plus 9. You can't just square both terms, because you've got two brackets, and each term in the first bracket multiplies each term in the second bracket, and you'll have two inner terms. So you'll have an x minus 3 minus 3x, and another x minus 3, another minus 3x. So you'll lose those terms if you just square both terms in the bracket. It doesn't quite work that way, but that's a very common mistake. So look out for it. So we write it as two separate brackets, x minus 3 times x minus 3. Next step, so we've got x times x, which is x squared. Then x times minus 3 minus 3x is exactly the same every time. So as you practice doing the same thing again and again and again. Then we've got the minus 3 in the first bracket times the x in the second bracket. That will give me another minus 3x. And then lastly, we've got minus 3 times minus 3 Minus times a minus is a plus, and 3 times 3 is 9, plus 9. Then we collect together the like terms. The like terms are minus 3, minus 3. So we've got minus 3, minus another 3, minus 6. So my final answer is x squared minus 6x plus 9, which Rob, Ikra, Simon, and Musa have all got perfectly right. Once you know how to do it, it's quite straightforward. It will just take practice. So, with that in mind, head over to your textbook. Exercise 13A, here's a screen grab of it. It's just got lots and lots of practice questions. So just go through, work all of these out step by step. You can use a grid method if you want at first, if it helps you to see where all the terms are coming from. Or you can use the FOIL method, as I called it there. The textbook that comes with your course. Here is a link to the textbook again. So if you want to click on this now, this is the foundation tier version of chapter 13 algebra. Here we go. And the answers are on your ICS Learn course page. So here is the link to the textbook. If you click on that now, if you're watching live, it will just pop up in another window and you can try that exercise 13A. Exercise 13B covers examples involving difference between two squares, and we'll go back to that in a minute. Don't do it now, no, just do it later on when the webinar has ended. But that bit goes with the thing that I've just taught, so just to say that. Now, the next thing I want to go on to is factorisation of quadratics. Quadratics, remember, are these expressions of the form ax squared plus bx plus c. If you're doing higher tier, you'll be doing a lot more work on these. For foundation tier, you just need to know what I'm doing in today's lesson. I won't go into the more complicated examples. So a quadratic expression is an expression that can be written in this form. It's got a squared term in it. That's the important thing to note. And we usually write it like this: ax squared plus bx plus c. The x's are variables, so they just stay as letters, and the a, b, and c are numbers, so they can be any number. If you're doing foundation tier, you won't have to factorize expressions where there's a number in front of the x squared. You'll just need to have things like, let's say, x squared plus bx plus c. I know I'm probably talking gibberish, but mathematically it makes sense, believe me. I'll show you some examples and then it should make sense. This is in both foundation and higher tier. So whether you're doing higher or foundation, you need everything that's in this lesson. All of Unit 3 covers grade 4 to 5 work, which you will need for foundation tier and will appear amongst the easiest questions on the higher tier paper. So everybody needs this. If you're doing foundation tier, the only content that you don't need to do is the content that's in Unit 4. Is that okay? So even if you don't know what tier you're doing, you will need this. It used to be higher tier only, but now it's in foundation. So don't worry about that too much. I'm not covering anything that's not in the foundation tier until I do the Unit 4 later on. So that's what a quadratic expression is. So factorizing a quadratic expression means writing it in brackets. So what we're going to do is the reverse of what we've just been doing. So what we've just been doing is multiplying out the brackets or expanding them. Factorizing means putting it back into brackets. I'm going to be doing a lot more work on this next lesson when I look at solving quadratic equations, because we use factorizing to solve quadratic equations. So make sure that you can do these really well so that we can see how we use this method then for quadratic equations later on. That's where this expression, quadratic expression, is equal to something. So remember, if there's no equal sign in it, it's called an expression. If there's an equal sign in it, it's called an equation, and then we can solve it. But for today, we're not solving anything. We're just working on the algebra, how to manipulate these. So remember, expanding brackets means multiplying them out like this. Factorizing means starting with the expression and putting it back into brackets again. Thanks for answering that question. Yeah, every Tuesday and Thursday, twice a week. So one is the reverse process of the other. How do we factorize a quadratic expression? It's a little bit tricky. It will take lots of practice, as all of these will. But as I said, if you're doing foundation tier, you only have to factorize quadratics of this form, where you've got a number in front of the x and then a number at the end. There won't be any number in front of the x squared term. And there'll be a lot more complex examples if you're doing higher tier, but I'm not going to cover those now. We'll cover them in Unit 4. Okie dokie. Ready. Let's see how this works. Note, I've put there, note that not all quadratic expressions can be factorised, but at foundation tier, if you're doing the foundation tier paper, all of the quadratics that you'll meet will be can be factorised. That's not always the case, and when we do quadratic graphs later on, I can show you why that happens. Okay, so the simplest quadratics to factorise, and the ones that we'll be doing in this study unit 3, are ones where the number in front of the x is just 1. So there's no number in front of the x squared term. We won't worry about those because they're harder. If you do want to practice them, use the higher tier, chapter 13. For now, just use the foundation tier one if you haven't done these before. So what you'll be asked in the exam is you'll be given a quadratic expression like this, x squared plus 5x plus 4, and you'll be asked to factorise it. So what you're being asked to do is put it back into brackets again. So you need to be very good at multiplying out brackets so that you can work on putting it back into brackets again. So the first thing to recognise is that this is going to need to go into 2 brackets with 2 terms in each bracket. So the first step would be to write your 2 sets of brackets like this. You know that x times x is x squared, so you need to put an x in each bracket like that to get this first term, x squared. Then we need to work out what numbers are going to go here and here to give us this term and this term. Now the last term is quite easy, that's 4. So that means that the 2 numbers at the end of both brackets multiplied together must give me 4. So what 2 numbers could they be? Well, it could be a 1 and a 4, or it could be a 2 and a 2. So those are my 2 possibilities. But then remember, when I multiply out these 2 brackets, I'm going to have 2 terms in x, and those 2 terms in x are going to give me the plus 5x in the middle. So it's a little bit of puzzling out what we need to do. So the first step when solving these is to put the x at the beginning of each bracket, then write down pairs of numbers that multiply together to give me the constant term at the end, the plus 4 at the end. So as I said, to get plus 4 here, I can either have 4 and 1, or I can have 2 and 2. Simon, I could have minus 1 and minus 4, but I'm not going to look at negative ones because I'll tell you, just to keep things simple, but also because I can see that this is plus 5x. So I know that if both of these are positive terms, then the 2 numbers in the brackets are going to be positive. It will take a little bit of practice to notice that, but that's basically how it works. If it was minus 1 and minus 4, then when I multiplied out that bracket, I would get minus x minus 4x, which is minus 5x, so that wouldn't be right anyway, so I can rule that out. So what I need to do in my next step is say, now which of these added together is going to give me the plus 5x. So by the time you do these, you should be quite good at multiplying these out. So remember that what happens is you do x times the number in the second bracket, and then x times the number in the first bracket from the first one. So those 2 will combine to make the middle term. So we need to choose the 2 that add together to make plus 5. So the 2 that add together to make plus 5 are these 2, 4 and 1. So those are the numbers that need to go into the brackets, and they will both be positive because plus 4x plus x gives me the 5x in the middle. Remember, the thing that we end up with has to multiply out to give the quadratic expression that we started with. We put those in the brackets there. So if we multiplied this out, we would get x times x, which gives me x squared, which is what I want. Then we would have x times plus 4, so we would have plus 4x. And then we would have plus 1 times x plus x. And then lastly, by design, because that's why we chose those numbers, plus 1 plus 4 is plus 4. So these 2 combine to make this term here in the middle, plus 5x. If you've never done these before, it will take a lot of practice, so just practice as many as you can until you can just work them out. It will take a lot of practice. Once you've mastered these and you're doing higher tier, you can go on to the more difficult examples that can be solved in different ways. Let's have a look at some more examples. So this time we've got a minus sign in the middle. So that means that some of my terms are going to have to be negative. So it's a little bit more difficult. So we've got x squared minus 8x plus 7. First step is to notice that it's a quadratic, and so it's going to have to be written in 2 brackets. So you write your 2 brackets. The first term is x squared, so put an x at the start of each bracket. That would be my first step, like this. And then we need to find these 2 numbers. So what number goes in here and what number goes in here. Note that it doesn't matter if you've done these in a different order. So let me just go back to this one. If you had written this as x plus 4 times x plus 1, that means exactly the same thing. It's like 2 times 3 means the same as 3 times 2. If you swap them around, it doesn't matter. You won't lose marks. It's just whatever way you prefer. So there's no rule about how to write these numbers in. As long as they're right, it doesn't matter if they're swapped around. So write your 2 brackets. And then we need to figure out what numbers go in there. So the first step will be to work out 2 numbers, find 2 numbers that multiply together to make plus 7. And we know it's going to involve something negative because we've got a negative number in here. So just on a separate piece of paper or just off to the side, or with practice you can do it in your head, let's write down pairs of numbers that multiply together to make plus 7. So we've got 1 and 7, because we know that 1 times 7 is plus 7. Or we could have minus 1 and minus 7. What do we need to put in those brackets? Well, if we add those 2 numbers together, it should give us the number in front of the x, minus 8. 1 plus 7 is plus 8, and minus 1 plus minus 7 is minus 8. So the pair of terms that we're going to need are the negative ones, minus 1 and minus 7. Does that make sense? Let's have a look. Let's put them to make, because we want to make minus 8 in the middle. So it's important. In fact, this will always happen. If you've got a negative term in the middle and a positive term at the end, then it means that both numbers in the brackets are going to be negative. With practice, you'll see why that's the case, because a minus times a minus is a plus. Then we have to have 2 negative numbers to make that minus sign in the middle. So in this case, the missing numbers are minus 1 and minus 7, or the other way around. Doesn't matter if you do x minus 7 times x minus 1, it's the same thing, so we put that in the bracket. So that is my final factorized form for this quadratic. X minus 1 times x minus 7. If you multiply that back out, x times x squared, x times minus 7 is minus 7x, then you've got the minus x, so that gives me the minus 8x. That's the middle term. Minus 1 times minus 7 is plus 7. Okay, so that's a little bit trickier because of the signs. Let's have a look at another example. This time we've got x squared plus x, which is the same as plus 1x, minus 6. We're just going to do exactly the same thing again. So the first step is to notice that this is a quadratic, so to write 2 brackets, like this. The terms at the start of each bracket are both going to be x. I suppose it could be other letters, but usually it will be x. It's unusual for it to be other letters, but it could be. Algebraically it could be, that would be fine, but usually it's x. So we've got x at the start of each bracket, x times x, it gives me the x squared. So I've got that, tick. There we go. Then what do those numbers need to be to multiply together to make minus 6? Now there's a few things that multiply together to make minus 6, because I've got 1 and 6, but then I've also got 2 times 3. Plus, I know that because this is minus 6, those numbers are going to have different signs, because to get a negative answer, if I'm multiplying 2 numbers together, it's going to be a positive number times a negative number. So we've got lots of different combinations there. And what we need to do is find the right combination so that those 2 numbers add together to make plus 1. With practice, you'll be able to do it straight away. But let's just write down the different combinations of things that multiply together to make minus 6. So we've got Sasha, 1 and 6, good. Well, we need to make minus 6, remember. So one of those has to be negative. If I wrote, if I did 1 times 6, that would give me plus 6. And what I want is actually minus 6. So be careful with the signs. So the actual numbers are right, but you've got the sign. So Michael, that's perfect. You could have 1 and you could have minus 6. That would work perfectly. What else could we have? Any suggestions? So Sasha, you could have -1 and +6, or you could have -6 and +1. And Muaza, I hope I'm saying your name right, you could have -2 times +3, or you could have -3 times +2. So that's all the different things that might go into these brackets. So all of these combinations might be the potential candidates for going into these brackets, but which one is it going to be? Well, it's going to be the one where those numbers add together to make +1. So if you work out 1 and -6, that gives me -5, so it can't be that one. If I work out -1 plus 6, same as 6 take away 1, that does seem to work. If I had used these two, 2 take away 3 is -1, so that doesn't work. And this one, -2 plus 3 is +1. So that, sorry, hold on, sorry, that works. That one doesn't. I'm going mad. -1 plus 6 is -5, so that does not work. Let me just cross that out there as being stupid. So the one that we want is the one at the bottom. So when I add together the two numbers, they have to add up to +1. And -2 plus 3, which is the same as 3 minus 2, is +1. So that's the two numbers. Those are the two numbers that are going to go into my brackets. Doesn't matter whether you put -2 in the first bracket and 3 in the second bracket, or 3 in the first bracket and -2 in the first bracket. But as long as you get those two numbers in there, that is my factorized form. So when you're working through these in the textbook and you're looking at the answers, it's not wrong if it's the other way around. You could have it either way, so don't worry too much if they're the other way around, because multiplying, it doesn't matter which order they go. And what this means is one bracket times the other bracket. So we put those in, -2 and 3, put that in the brackets. We've got x minus 2 times x plus 3. But if you had written it, let me just write this to be clear. If you've written it as x plus 3, I hope that looks like a plus sign. I'm still struggling writing with a mouse. And then this is x minus 2. Then that is also completely correct. So it's just a different way of writing the same thing. It often happens in maths that things can be written in two different ways. Sorry, so you can put the plus 3 in the bracket 2. Yeah, so you could write it as x plus 3 times x minus 2. That means exactly the same as x minus 2 times x plus 3. Both of those multiplied out would take you back to the beginning, which is what I'm looking for. So that these could be written the other way around. So if you've written it, if you're checking your work in the book in the answer section, and the brackets are swapped around, is still absolutely correct. There's no rule about what order those should go in. It's just however you found it. Is that okay? It just takes lots of practice. Whoops. There we go. So that's our final answer. So lots of practice. So go to exercise 13C in the book. I gave you the link to chapter 13 earlier. If you're doing for higher tier, just work through the foundation tier questions for now. You can go on to the more difficult higher tier version later on when I go on to the more difficult examples of quadratics. But make sure you can factorize these simple cases very well first before you go on to the higher tier ones. If there's something you've done before and you want to just go straight into the higher tier book and look at the more difficult examples, you can. But it's also perfectly fine to do foundation tier now and go on to the harder examples in the higher tier book later. Okay, so lots of practice questions. So for example, this one I can do very quickly. I would just go equals, open bracket. We've got x in the first bracket, and we must have x in the second bracket because we've got x squared at the start. I'm just picking this one at random. Can anyone spot what I need to do? So the next step would be to look at the 12. Oh, 12 has got lots of factors, but it's a plus 12. Both of these are pluses, so we're not going to have any negative numbers in here. Let me just change the colour. And I would say, that's not very good, I'll choose blue. What pairs of numbers multiply together to give me 12? Well, I could have 1 times 12. You've probably spotted already. I could have 2 times 6. And I could have 3 times 4. And then I need to look at the middle value. So the middle value is 7x. And I need to say which of these numbers written in blue here, which pair of numbers add up to 7? Well, 3 plus 4 is 7. So those are my my numbers that need to go in my brackets. It doesn't matter whether I write +4 in the first bracket and 3 in the second bracket. It doesn't matter what order they go in. I'd probably put them in numerical order there, those. So +3, +4, which add up to the 7x in the middle. Okay, so just takes practice, and all of these expressions here you should be able to factorize using this method. Try at least the first few questions. There's some more difficult examples later on in the exercise, but as a minimum, if you're doing foundation here, make sure you can answer factorize these types of quadratics. One last thing, and that is, oh, I haven't animated that very well, but I think I missed a slide. And that is to factorize a difference between two squares, and I briefly mentioned that a moment ago, but let's have a look at what that means. So if you have a bracket of the form a minus b times a minus b times a plus b, a and b can be numbers or terms, doesn't matter, but let's have a look at this special case, difference of two squares, see what happens when we multiply a bracket like this. So if we were to multiply this out, multiply every term in the first bracket by every term in the second bracket, what would happen? Well, we would have a times a, so remember the first term in the first bracket by the first term in the second bracket is a squared. Then a times b gives me plus ab. Then minus b times a, so the minus b in the first bracket times the a in the second bracket, minus ab. And then minus b times plus b. That gives me minus b squared. And what happens if we have something like this? So we have something minus something. I'm saying something because I want to avoid using algebra. Algebra is the best way to explain it. So if I had something like this, let me just give you an example. Save me saying something. Is that going to work? So if I had something like x minus 5, like this, times x plus 5. Like that. So a and b can be any number or any term. What would happen? So it's important that you can recognize expressions of this form because it's like a special case. Yes, they would cancel out. Well done. I was kind of waffling on a little bit there to see if you would spot that. So what will always happen in this case, where you've got a minus, the same two terms in the bracket, but one's got a minus sign and one's got a plus sign. What will happen is that these terms in the middle will cancel out. So plus AB minus AB is nothing, 0. So they disappear, they cancel out. And that will always happen if I multiply out two brackets like that in that form. And what we end up with is the square of the first number minus the square of the second number or term. That's why it's called the difference between two squares. A squared minus b squared. So remember, in maths, difference means subtract and squared means to the power of 2. So anything in the form a squared minus b squared is called a difference of two squares. A difference of two squares. So we could have something like 4 minus x squared. That would be a difference of two squares because 4 is a square number and x squared is a square number. We could have 121 b squared. Whoops. Subtract a squared. My pen's going funny. A squared c squared. That's supposed to be a 2, by the way. It's not very well written, is it? That would be a difference of two squares. And the reason it's important to be able to recognize these is because if I asked you to factorize something and you spotted that it was a difference between two squares, you would factorize it by putting it into brackets like this. So you would factorize it by putting it into brackets where you've got the square of the first term minus the square of the second term multiplied by the square of the first term plus the square of the second term. It doesn't strictly matter whether you get the plus and the minus the other way around, as long as you've got the same two things multiplied by each other. Let's have a look at a couple of examples. The hardest thing with these type of questions is spotting that it is a difference of two squares. probably the easiest way of spotting it is it will have just two terms in it. So you'll be asked to factorize something that's got two terms in it, separated by a minus sign, and they're both square terms. And that can always be factorized like this. It's just a slightly neater version. So here's some examples. And we're being asked to factorize it. Now we're being told that these are all the difference of two squares, so it makes it a lot easier. In an exam, you wouldn't be told. You would just be told to factorize this expression, and you would have to spot that it was of this special case, a difference between two squares. Why are all of these a difference between two squares? Well, because 4 is a squared number, it's separated by a minus sign, and then x is a square number. This is a square number. 9n squared is just 3n times 3n, so 3n squared. That's a square number. Separated by a minus sign, and then 16 is a square number. And then this last one, we've got a squared b squared. That's just the same as ab squared, or ab times ab, so that's a square number. And we've got the minus sign, has to be a minus sign, otherwise it's not a difference between two squares. Difference means subtract. And then we've got a 1 at the end, and 1 is a square number because 1 is just 1 squared. So let's put these into brackets. Muazza, you think the first one, and I'm assuming you're guessing because you're putting a question mark there. The first step is going to be to write two brackets. So let me just rub this out. So you notice that these are the difference between two squares. Let's put the brackets in. So we're going to factorize them. So that's going to be equal to open bracket, open bracket, open bracket, open bracket. Minus in there, plus in there. What times what equals 4? So what's the square root of 4? Is 2. So we put 2 in the first bracket, 2 in the second bracket. And then what times what equals x squared? X times x equals x squared. So x in the first bracket, x in the second bracket. So that's how you write it. That's how you factorize a difference between two squares. Let's have a look and see if we're correct. Does anybody want to have a go at part B? So type it into the chat box if you can have a guess. So what we need to do is the difference between two squares. So we're going to write our two brackets. One's going to have a minus in, one's going to have a plus in. But it doesn't matter if you do it the other way around, it still comes to the same thing. Then the first terms in both of those are going to be the square root of 9n squared. So what do we multiply by itself to get 9n squared? Well, 3 times 3 is 9. So we're going to have a 3 at the start of each of these brackets. And then to get the n squared, we need to have n times n. So n times n. So 3n at the start of both brackets. And then we've got 16. What times what equals 16? What number squared will give me 16? In other words, what's the square root of 16? 4. Thank you. So we put the 4 in here and the 4 in here. So to factorize this expression, we've got, and my writing's a bit messy, I'll show you it in a second, 3n minus 4 times 3n plus 4. And if I multiplied that out, the 2n terms would cancel out, and I would just get back to the expression I started with, which is what I want. So 3n minus 4, 3n plus 4. How about this last one? So again, I would start by saying, okay, I'll put this into my two brackets. What do I need to multiply by itself to get a squared b squared? So we put the signs in, so I know that's going to be the plus and the minus and a plus. To get a squared b squared, I need to multiply, good Rob, brilliant, that looks perfect, ab by ab. So we just have the ab here at the start of both brackets, because ab times ab is a squared b squared. And then to get the 1, I need to do 1 times 1. Square root of 1 is just 1, so put that in there. Take a little bit of practice, as with all of these. So I've got ab times ab gives me the ab squared, and then the minus 1 times the plus 1 gives me the minus 1 at the end, and then the two middle terms cancel out. If I was to expand this, I would get minus AB plus AB, which would give me just 0. They would cancel out. So difference between two squares. It takes a lot of practice to be able to spot these, but if you're managing to do these, you're doing really well. Okay. For more practice, if you do exercise 13b first, 13b has got some examples of multiplying these out. So if you multiply these out, then you spot the pattern, and then you'll be able to do the reverse process, which is to put the brackets back in. And these expressions here in exercise 13d number 1 are all differences between two squares. So you can put them back into brackets again, so you're doing the reverse process. So work through those. If you can get the whole of chapter 13 done, practice the questions. You can do some of the problem solving things as well, but the priority will just be to make sure that you understand the basic method. Next lesson, I'm going to go on to solving simple quadratic equations using factorisation, a new topic to foundations here. So we'll be doing plenty more practice of this kind of factorisation, and we'll be using that to solve quadratic equations, which are just equations which are quadratic expressions equal to 0, and then we need to find the possible value of x which can solve that equation. So it's just a similar technique but in a different context. If you want to see some more worked examples, there are some on Hegarty Maths. So hopefully you've created a Hegarty Maths account, because every time you watch these videos you need to just log in. But if you click to remember that, then these should open up for you. So there's some more videos there. Click on those links and hopefully they'll work. So just click on those and that will open up those videos. Log in if you need to. Once you've logged in, you'll be able to just click on the link directly. The first video there shows some examples of expanding double brackets. The second one is doing the reverse factorising. Please be aware that if you're doing foundation tier, you don't need to do harder examples. You don't need to know the quadratic formula. You don't need to know how to solve a quadratic by completing the square. You don't need to be able to do expressions where there's a number in front of the x squared. You'll only need to do the basics. So if that does come up, because this used to be only higher tier, don't worry about it too much. Only people who are doing higher tier will need to do the more difficult examples. And then there's a good worksheet here which has a whole mixture of expressions, all different ones that go in one bracket, ones that go in two brackets, and then the factorisation of those, and including the difference of two squares. So some really good practice questions in there on the Maths.up website. So that's all from me today. If you need help, sorry, I was just going to link to MathBuster, so people are doing MathBuster. This is a view of the foundation tier MathBuster. If you go to section 37 and 38, these are grade 5 topics here. You can get some more practice questions there. So if you want to have a look at MathBuster, if you're in the UK, it costs £12.99. It's really, really worth it because there's lots of practice questions, there's videos, it marks everything as you go through, it gives you practice tests with all mixtures of questions, so it's a really good thing to get for revision if you want to try that. Does anyone have any questions before I let you go? As I said, if you're doing higher tier, I'll be covering more difficult quadratics in Unit 4, in lessons 54 and lesson 55. So I'm not neglecting higher tier students. I will go on to the more difficult examples later on in the course, towards the end of March if you're watching the live lessons. And next lesson, I'm going to cover quadratic equations. So make sure you get lots of practice, particularly of factorisation, before you try next lesson, number 37, on quadratic equations. And I'll see you then on Thursday if you're watching the live lessons or in the next recording. Okay, bye. Oh, hello, Daniel's just introducing himself there. That's fine. Does anyone have any questions before I end the session? You can contact me anytime. I work here full time, so you can contact me here in the office. I gave you my details already, but they're here. You can also ask for help using any of these forums, or you can contact your tutor and they'd be happy to help you with any of the questions if you're struggling. Oh, you couldn't find the chat panel, Daniel. Sometimes I think because of this new view, you need to click on where it says chat. There's a little sort of arrow like that, and it should pop up for you. That's probably why I didn't hear from you during the session. If you come next time, open that up or I just suppose you can't really ask me if you can't type into the chat panel. So I'm glad you found it in the end. All right, bye everyone, and I'll see you next lesson, quadratic equations. And if you need any help, let me know. Bye.